In this lesson, you will learn about the properties of exponents. Let's take a look at some notes and examples that better explain these properties. To better understand the properties of exponents, you must first understand some basic vocabulary. The first one we'll look at is the word monomial. The word mono means one. Monomial means one term. And in this case, it means one term with no plus or minus signs. So in this lesson, each term you will be looking at will be monomials. An example of a monomial might be 3x squared y. 3x squared y is a monomial. It's considered to be one term because there are no plus or minus signs separating the 3, the x squared, or the y. So they are considered to be one term. The second word you must understand is the word base. And you may have heard this word before. If you look at the expression 3 squared, you probably know that the 2 is called the exponent. But you may or may not know that the larger number is called the base. And I will be referring to the word base throughout this lesson as we learn about the different properties of exponents. So let's now scroll down and take a look at our first property. The first property of exponents we will look at is called the product of powers. Now, it's not important that you memorize the word product of powers. What's important is you simply understand what it means. The product of powers tells you to multiply two powers with the same base, add the exponents. So looking at this example over here, it says again to multiply two powers, which would be like this: a to the m times a to the n. That is showing that we are multiplying two powers. And it tells us to add the exponents together. So as long as the bases, which would be the a's, are the same, we're going to add the exponents, which is shown here. Now let's see what that looks like in an actual problem. So looking at this first example, x squared times x cubed. Notice the bases are the same. So because they are being multiplied, you can actually combine them together by simply adding their exponents. So it'd be x and then to the 2 plus 3, which is x to the 5th power, which would be your answer. Look down at example 2. This time we have y to the 4th times y to the 5th times y. In all three, the bases are the same, and we are multiplying these three together. Because the bases are the same, we can add their exponents. So it would look like this: 4 plus 5. And for this last y, when you do not see an exponent, it means its exponent is 1. So we still need to make sure and add the 1 when we get our answer. So this would give us y to the 10th power for our final answer. In the next example, our bases are now numbers rather than variables. Because they are the same, again, we just transfer that base over and we add the exponents. Do not multiply the 2's or add the 2's. Keep the base the same as we did with the variables. Simply add the exponents together, giving us 2 to the 6th power. But if the base is a number and the exponent's not too large, you want to actually calculate 2 to the 6th power. So 2 times 2 times 2 times 2 times 2 times 2. And if you went ahead and calculated that, you would end up with 64 for your answer. In the last example of the product of powers, notice you have two larger monomials that are being multiplied. Now, the numbers in front, because even though those are bases, they are not the same, those numbers can simply be multiplied together, giving us 8. Now, if you look at the second variable, the a, because those are the same base, you will add those exponents. So it would look like this: 2 plus 4. Then the same for the b's. Because the bases are the same, you will add the exponents, Give the first b a 1, so it'd be 1 plus 3. So if we go ahead and add those exponents, our final answer would be 8, a to the 6th, b to the 4th. Let's scroll down and take a look at the second property of exponents. The second property of exponents is called the power of a power rule. It says to find the power of a power, just multiply the exponents. So what that looks like, if you look at this little example here, is when you have a monomial raised to a power, such as this, a to the m raised to the nth power. What you do in this case is simply multiply the exponents. This is the same as using the distributive property, which you've learned at an earlier time. Because you're distributing the exponent outside parentheses to each exponent inside, distributing is multiplying. So looking at this first example, you would take the 5 and multiply it by each exponent inside parentheses. So 5 times 3 gives us 15. So b to the 15th would be our answer. In the second example, you will distribute the 7, which means multiply it to the 6th. So it would look like this, g to the 6 times 7. And then 6 times 7 is 42. In the last example, you'll distribute the 2. So it'd be 2 to the 6th power. But in this case, because the base is a number, you're going to actually calculate 2 to the 6th power, which is 2 times 2 times 2 times 2 times 2 times 2. And you would get 64 for your final answer. Let's take a look at the third property of exponents called power of a product. To find the power of a product, you distribute the exponent outside parentheses to each base inside parentheses. So this is very similar to the second property. It's just that you will have more than one base inside the parentheses. So looking at our first example, the m is going to be distributed to both the a and the b because they are separate bases. So if you look at this example here, because 2 is a base and x is a base, the 3 will be distributed to both, as you can see here. The final thing, as usual, is if the base is a number, as in 2 to the 3rd, you will simplify it, and 2 times 2 times 2 equals 8. Let's try the next example. 4y, all raised to the 2nd power. There are 2 bases in the parentheses, the 4 and the y. And the 2 needs to be distributed to both bases. So that would be 4 squared y squared. We then need to make sure that our base, which is a number, is actually calculated. So 4 squared is 16. And then we just bring the y squared over. In this last example for power of a product, you have 3 bases, -3, x, and y, inside parentheses. So the 3 needs to be distributed to all 3 of those bases. So we will have -3 raised to the 3rd power, x to the 3rd power, and then y to the 9th power because we're multiplying the 3 times the 3 that's already there. We have a number that's a base, so we will go ahead and calculate -3 to the 3rd power, which is -3 times -3 times -3. And if you actually calculate that, we would get 9 times -3, which is -27. And we would just bring over the x cubed y to the 9th. Let's now take a look at the fourth property of exponents. The next property is quotient of powers. Quotient means divide. So it says to divide 2 powers with the same base, this time we will subtract the exponents. So looking at our example here, again, the a's are the same base, and it's showing that the exponents will be subtracted to combine them together. So in this example, with the c's, we simply take our exponents 11 and 8 and subtract them to combine them together, giving us c cubed as our answer. So let's try the next example. Notice the r's are the same, so the bases are the same. So because we're dividing two expressions, we will simply subtract the exponents, leaving us with r cubed. In this next example, we have two bases in the numerator and two bases in the denominator. So treat them separately. Take your x and subtract the exponents of the x's since they are being divided. The expressions are being divided. Then look at the y's and take their exponents and subtract them. So our final answer would be x squared y to the fourth power. We will next take a look at the power of a quotient. In power of a quotient, you will have a fraction in parentheses and an exponent outside. Similar to a previous property, we will distribute the m to each base in the parentheses, in this case to the numerator as well as the denominator. So notice both the a and the b now have an exponent of m. So in this example, we want to give the 3 to the r and to the t. So it will be r cubed over t cubed. In the next example, we have two bases in the numerator, so the 3 will be distributed to both, and one base in the denominator, which the 3 will be distributed to. So we'll have 3 cubed x to the 9th in the numerator and x cubed in the denominator. We then have two things left to do. We need to simplify 3 cubed because the base is a number, and to combine our x's together, because they are being divided, we simply need to subtract their exponents. So 3 cubed is 27. Then we need to subtract the 9 and the 3, leaving us with a final answer of 27x to the 6th power. Let's take a look at power of 0. The power of 0 tells you that any base raised to the 0 power equals 1. And that's something that you are going to see throughout this unit. So make sure anytime you see any base raised to a 0 power, you just automatically put a 1, not a 0. So for example, 3 to the 0 power equals 1. 200 to the 0 power equals 1. Even when an expression like 4x is raised to the 0 power, you can put 1. And then in some cases, when you're using the quotient property and the bases are the same, and you subtract the exponents, once you subtract, if you end up with 0, then 3 to the 0 power gives you a final answer of 1. Now we're going to do some examples and put all of these properties together. In this first example, we don't have any exponents to distribute outside the parentheses, so we're simply going to look at the bases that are different and the ones that are the same. The 3 and the -5 are different bases, so because this is a multiplication problem, we will simply multiply those numbers together, which would be -15. For the variables, because the b's are the same base, we can add those exponents together. So our final answer will be -15 b to the 8th power. In problem 2, this time we have an exponent outside each set of parentheses. So we will first need to distribute the exponents to each base inside the parentheses. So this would leave us with -3 to the 2nd power, a to the 4th power, b squared for our first set of parentheses. And then we'll have 2 cubed, a to the 6th, b to the 9th for our second set of parentheses. From here, we have many things to do. We might first simplify the bases that are numbers, leaving us with 9, a to the 4th, b squared, times 8, a to the 6th, b to the 9th. From there, the numbers that are not the same base, we can simply multiply together, giving us 72. And then the variables that are the same, which means the bases are the same, we will add those exponents. So for the a's, we will add 4 and 6, and for the b's, we will add 2 and 9. So the final answer is 72, a to the 10th, b to the 11th. In example 3, we have many things we need to do, and then you have different options as to how you begin. You could either distribute the 2 to every base in the parentheses, both in the numerator and the denominator, or you could simplify what's already in the parentheses first and then distribute the 2, whichever you feel is easier. So what I think I will do is I will first simplify what's in the parentheses and then distribute the 2. So what I need to simplify is 3 over 6. I can reduce to 1/2. Because the m's are being divided, I can subtract their exponents to combine them together. And the n's are also being divided, so again I can subtract their exponents to combine them together. Just make sure you bring down the 2, as that will be used shortly. From here, I will go ahead and subtract the exponents of the m and the n. Now I'm ready to distribute the 2 to every base inside the parenthesis. So that would give me 1/2 squared m squared n to the 10th. And because I have a base that is a number, I need to go ahead and calculate 1/2 squared, which simply means 1/2 times 1/2, which would be 1/4. And then I can just drop down m squared n to the 10th. And that completes the lesson on the properties of exponents.